Hello dear students, in this lecture we will see another application of some methods. We can say the correlation method to detect spike and wave that is present in an EEG signal. So you remember what we mean by spike and wave. So today we will see a method that is template matching for EEG spike and wave detection. So we will discuss, and in this we will assume that we are having a sample segment, that we can say a template, that is of spike and wave complex, and we will assume that it is already available to us. So how we will detect that spike and wave complexes in other EEG signal? So we know that a spike and wave complex is a well-defined event in an EEG signal, and this complex is composed of a sharp spike followed by a wave with a frequency of about 3 Hz. So that makes spike and wave complex. The template which we have, like we are assuming that we have one template, so what we will do is the template will be correlated. So again in this we will use the application of correlation, so that template will be correlated with the same channel from which it was extracted to detect the similar events that appear at a later time, or we can also use cross correlation function if we want to detect that spike and wave complex in another channel, we can say. So for same channel we can use autocorrelation function, and for different channel we can go for cross correlation function. So mainly we will use a template that we are assuming that it is already available to us, and then we will apply correlation, and then we can use a simple threshold to give time instance where that events appear. So you can see this one illustration we will see. So this is a figure showing C3 channel of the EEG signal, and if you see, it has different spike and wave regions. These are all showing spike and wave complexes. And now we will take a template, means we will choose one template, and we are assuming the template between 0.6 to, we can say, 0.82 seconds. So this we are taking as a template. So we are taking this spike and wave complex in the region of 0.6 this to 0.82. So this basically peak spike and wave complex we are choosing as a template. Now what we have to do is we have to use correlation function. So in this we will use normalized correlation coefficient. We will use to calculate or to perform the template matching with the same channel signal. So first we will do with same channel signal, and you can see this equation. So this is the equation for finding normalized correlation coefficient. Normalized means it will have values between -1 to 1. So it will give the value, and you can see how it is coming. So this is the correlation function, normalized correlation function, and it demonstrates strong and clear peaks at each occurrence of the spike and wave complex in the EEG signal. So what we are doing is we are choosing one template, and then we are taking that template and we are correlating the signal with that template. What will happen? Wherever that peak will come, or we can say spike and complex will come in the signal corresponding to template, it will show the peak, otherwise it will show a kind of dip. So the peaks occur at the same instant of time as the corresponding spike and wave complexes. You can see, let's suppose we see this 0.6. So you can see in the previous test we have this at 0.6 you are having a spike and wave complex. So it is showing a peak. Fine. So this is how we can find out the spike and wave complexes in a particular channel. Now let's see another example. Now this is F3 channel of the EEG signal, and again it is showing some spike and wave complexes. Now what we are doing is, now this is F3 channel and the template which we are using is from the previous channel, means C3, and like that here we have chosen this in the range of 0.60 to 82 second. So this template only we are using, but now we are not correlating with C3 channel, but what we are doing, we are correlating with F3 channel. So now it is kind of cross correlation we are performing, because template is of some other channel, but we have to find those spike and wave complexes in another channel. So template is from C3 and channel now where we want to find that spike and wave activity is basically from F3 channel. So you can see the result. It shows that the F3 channel has spike and wave activity complexes that match the template. So wherever the template will match with this, so it will show the peak, otherwise it will not show the peak. So that is how we can apply the same method to one channel, to the same channel, or we can say to the other channel. We can use correlation coefficient, normalized correlation coefficient, to find out the spike and wave complexes. So for this you can again go for reference this book, Rangaraj M. Rangayan, Biomedical Signal Analysis. So for now, thank you so much.